All right, so I'm live with 52 weeks of live coding with MLOps. So last week, what I covered was just playing around with some of the options for TensorFlow, and where I wanted to cover next, though, is and I haven't dug into this too much, is what are the options for serving out a pre-trained model from TensorFlow. And so what I'm hoping to do with some of these live coding sessions is to not do too much work necessarily upfront, because there's an infinite amount of things you can study with MLOps, and I'll just hopefully fumble through some of the things that I'm trying to learn and share that knowledge with you, and maybe that'll be helpful as well, because you may have a similar kind of problem, and hopefully some of my troubleshooting will be helpful to you. So the first thing I guess I'll start with is to go ahead and create kind of dive into Collab here and share my screen. So we'll go ahead and do that. We'll go ahead and share my screen here for Collab. And so now if I was going to investigate a new thing again, like for example, how to serve out pre-trained models with TensorFlow, I would probably start off with looking at Collab, since I'm in the Google ecosystem. And what do we got here? So we have, machine learning. Let's take a look at machine learning. And I'm going to just look at their documentation here and see if I can find anything that will be helpful. So it says Collab is used in the machine learning community for doing TensorFlow, experimenting with TPUs, creating tutorials. So that's good. So let's look at what the resources are that are available. We have working with notebooks. We don't need that. Working with data. We don't need that. Machine learning crash course. Okay, maybe we're getting somewhere. And then using accelerated hardware, which is kind of interesting. So there might be something here. And then also we have these featured examples here. So retraining an image classifier, which is kind of interesting, but I really want to figure out how to just serve out a model that I didn't build myself. And so I'm going to click on this one and see what they give me. So this notebook provides an introduction to computing on GPU and observe the speed up. Okay, so let's see if this helps us, or it doesn't give me an example. So I don't see an example. So what I might have to do is go to TF Hub and keep kind of going through here and finding more stuff. So TF Hub, if you're not familiar, is basically where the pre-trained models live. So I'm hoping that what I can do is find out some instructions about what TensorFlow would recommend for me in order to run a pre-trained model. So let's go ahead and look at some info. So we see here TensorFlow Hub is a repository for machine learning models. Find a trained model and save time on training, or publish your own model, or deploy the models on a device and in the browser. So that's more like what I'm kind of interested in. And so if we take something kind of simple, maybe let's take a classification problem here, and we can look through what are the different things that are available. So this is a collection of image models by Google. Okay, let's click on this. So we can see that it says for image classification, there are two kinds of modules available. You can do image classification. And so this will identify the classes the model has been trained for. And you can also do extract feature vectors as well. So in this particular example, we see here's the hub. We go through and we download this, and here's the examples that we actually have here if we wanted to use, for example, the classification example. So this looks pretty good, but what I want them to tell me how to do, if I wanted to take, let's say, the classification model, we can see that we could deploy it with JavaScript, which is okay, but I actually want to see a little bit more here, because I don't want to just deploy JavaScript. I want to serve out a TF Lite model. And so that's really what I want to figure out. So let's go ahead and just Google it, right? So serve out TF Lite model. What are our options here available? So here we go. TensorFlow Lite. let's go ahead and take a look at this. So TensorFlow Lite is a set of tools that enables on-device machine learning by developers. And so it has support for Android, iOS, embedded Linux, and microcontrollers, in examples for common tasks. So we might be getting somewhere here. And so generate a TensorFlow Lite model. And it does it in a format called flat buffers. And this provides several advantages over TensorFlow protocol buffer because it's smaller. Okay, that's good. And use an existing. That's again what I want to refer to. And what I really want to get to is this. I want to run inference or prediction. And so I can either use a model without metadata or I can use a model with metadata. You can leverage the out-of-box APIs using the TensorFlow Lite task library or build a custom inference pipeline with TensorFlow Lite support library. So this is looking maybe like what I would want to start with. That's really simple. And so you can refer to the following guides based on your target device. Now, one issue I see here, and I have actually done a lot of work with Android and iOS and embedded Linux because I have the Coral device itself, which has a TPU on it. But I don't necessarily want any of these right now. I want something that's none of that. And so I'm going to do one last look here. And let's see, we have image classification. See, I don't want it on any of these. I want to try it on just standalone. So that's kind of a bummer that the TF Lite here doesn't have any examples for me to try it on my own. So what I'm going to have to do is say TensorFlow Serve pre-trained model. Let's see if my TensorFlow Lite is what threw me off. So here we go. We have train and serve a TensorFlow model with TensorFlow serving. This is looking like more like what I wanted to get at. And this looks promising here. This looks pretty promising. Save the model, examine your saved model here. Add TensorFlow serving distribution as a package source. This does appear to potentially be a solution that I could use. So we got one thing cooking here that I could try to build very quickly. So this says this one's designed to be run in Collab only. I don't necessarily want to run this in Collab. So that's one of my problems here. But let me think about this. So maybe let's look at this. What does it need? Keras has got this. Save your model, TensorFlow. I think I could get this to run in, let's say, Google Code Spaces, though. Let's see if we can get this to run. So what I'm going to do is I'm going to go to GitHub, and I think I have some MLOps repo here. And let's just create a new repo, I guess. We can call this, MLOps in action. What's this? No, let's just make a new repo. Let's make a new repo here. So I'm going to go to new, and I'm going to build out a serve TensorFlow. So serve TensorFlow model, and let's just start hacking away. It's very possible I completely fail, but I also might succeed. That's what makes it kind of fun. And I'm going to build this out. So once I've got this repo, then I'm going to click on this code link. I need to make some more code spaces. So I'm going to go to code spaces, delete, I don't know, like the last one I did recently. Okay. And then I'm going to go back here and use this code space here. So I'm going to say code, refresh, and build this out. Perfect. Now, what I can do as well is just put this as a link inside the documentation of my project so that I can tell people where I was actually trying to reproduce some things. So let's go ahead and go to README and say, like, we'll say based on this, say, based on this idea. Now, here we get into a little bit of the complexity of doing anything with software engineering is that I would recommend you start with a makefile. Even though it seems like it's more work, let's do it because a makefile just really solves a lot of problems for me. And I'm going to go ahead and grab a makefile from something that I would probably fit reasonably well. So I'm going to go ahead and grab this makefile and throw this in there. And the reason I do this is I feel like it saves me time to make a makefile. And so the other thing I'll need to do is create a requirements file right here, requirements.txt. And that way I can put the libraries that I need inside of here very easily. And then I'll create a virtual environment. So those are the three things that I typically would recommend. And then what I would do is I would source this as well automatically inside of my bash RC, just so that I don't have to mess with this ever again. I hate needing to create virtual environments, but they solve a lot of problems. And so what I'll do is I'll say source this virtual environment and activate. There we go. So we got this cooking. Everything's looking good here. And now I need to find out what libraries to use. So I really don't know yet. And so hopefully they'll tell me what libraries. In fact, it looks like install dependencies for Collab environments. Well, we're going to get into some fun stuff here because there are some libraries that we just don't know what version they'll run in. Now, we could hack this actually. Let me try to hack this a little bit, because what I'm going to do is I'm going to connect to a hosted runtime, and I'm going to change, okay, GPU, high RAM, that's good. And what I'll actually say is I'll say run everything. Although I don't know if I need GPU. That could be a bad idea, but we'll find this out. So once I install all the software, what I can do here is I can actually create a command that tells me what options are available. So I can do this. I can say pip freeze. And if I want to be lazy, what this will do is it'll tell me the packages that Collab ran. And then when I go to recreate this, I can put this inside of my GitHub Codespaces environment and kind of turn it more into a software engineering project. So that hopefully will run. Don't know why that's taking a while. This should be running here. Oh, maybe. Oh, I see. So it's, let's just stop some of this because I don't need this right now. And let's go to here and let's just run this pip freeze. There we go. So probably too much code here to I probably don't need all this stuff. And so that is a little bit annoying. Well, what we can do is we can just grep some things. We can say grep TensorFlow, and we just do it one at a time. So we see TensorFlow version. We'll just say 2.80. Let's try that. So I'm going to go through here and say TensorFlow equals. Now, if I do make install, what happens? Does that work? Equal. Sorry, there we go. Equal. So in theory, that should solve a little bit of it, which is I can install the right version of TensorFlow that this was running with. And then I also could do NumPy and matplotlib. I think that's all I need. NumPy, matplotlib. So this could be easy. So let's do NumPy. There we go. Let's do that one. Here we go. Let's do the last one, which is matplotlib. So the idea with the freeze here is that basically in case they blow up one of these packages in the future and someone wants to reproduce what I'm doing, it probably will work for them to just do a make install, which is helpful to people or even to myself, right? If I was going to go through and try to reproduce what I did earlier. So that's promising. That's actually a good sign here that we got something working, and maybe even do like PyLint, because maybe I'll need that in the future. But this is a good sign so far. And the difference here is that the Collab notebook is a Jupyter-based environment, so it's a very different style of development. And the GitHub Codespaces is a software engineering based environment. So this is more like the Collab notebook is for the data scientist, and the GitHub Codespace is a little more towards the ML ops or ML engineer. And so that is something to be aware of, is that there are some differences here between these two kinds of environments. Okay, let's go ahead and do this. And I see a comment here while it's running. Yes, recorded and distributed. Okay, so we got this thing cooking here. PyLint looks good. Let's do that one more time. Make install. We even have PyLint, hopefully install. Okay, great. Now I can go back here to just grab some of the code. So I'm gonna grab this, and we'll just keep running it step by step. So first I need to make something. So let's create a file called main.py, and then I'm going to paste this inside of there, and let's see, does anything work? This is always a good place to start. Does anything work? So if I run Python main, ooh, that's not good, because we don't need this. We don't need any kind of a custom commands from Collab, which are the exclamation points. So if I run it again, we have success. There we go. So it says couldn't load this error, no such file. Ignore this if you don't have a GPU. Yes, we don't have a GPU, so we're good. NumPy failed to import. That's not as good. Module compiled against API version, but this version is NumPy. So that's not as good. It sounds like we have some kind of weird NumPy error. And what can I do to fix that? It's probably something to do with GitHub Codespaces. And let me see here. Let's even put in GitHub Codespaces here. And let's see. This is issue is happening. What do I do? Let's says I get the same issues. Well, what we could do here is actually just maybe one of the problems that we could fix. I mean, this is unfortunate. These are the kind of things that happen in a real world project. Is let's actually just do this. Let's get a little bit crazy here, and let's take out the versions, because there could be some weird stuff going on. And let's actually just do the versions that are not pinned first. That's another way to get around issues. Install here. Let's go ahead and run this. And now, if I say Python main, didn't really fix it. So import error, failed to import. Let's try that. What is it saying? Pip install. What's wrong? Pip install. Oh, updating. Okay, let's try that. Pip install update NumPy. Okay. That could have been because I had the old version of NumPy. Okay, so we have something working. Okay, good. Now the next step here, we have part of it working, is we want to use the MNIST data. So let's go ahead and put that in there next. And let's go back to here, and let's go to main, and we'll say this is basically the MNIST data here. So we'll say MNIST. Okay, let's see, does this work? And that's a good sign. Boom, there we go. We got that working. Next up here, we can train the model and evaluate it. Okay, let's do that. Let's go back here, train the model and evaluate it. Train and eval. There we go. Let's go ahead and save that. And does this work? It's looking good. We can train it. It's going to be slower, obviously, because it's on a GPU system, but not horrible. It doesn't look like, because we're only going to do 5 epochs. There we go. Now, I don't know if I would always want to do this exact workflow. I think in the future, getting a pre-trained model would be the way to go. But okay, this looks good enough. And then what do I do next? We want to save the file, right? So again, I could probably break these up into 2 sections, which is like create model, serve model. In fact, I might even just do that. But let's see here. So this is save model. So save model here. Hey, come on. Let's see if this works. And let's just do up arrow here. We need to get rid of this export path. We want to, we don't need that, because let's see, export path, print export path. Yeah, so I think it's already printing the export path. We don't need to do this. Save model. In fact, what we could do is do an F string here and say export path. We don't need that weird stuff from Collab notebook syntax. So let's actually do that. Python main. So it's going to have, unfortunately, this is why it's good to break it into 2 sections, is that we don't want to train it every single time. It's just a waste of our time here. So if this works though, which I believe it will, then we have essentially the train component, and now we'll have the serve component. So let's go ahead and try this out. Does it work? Ooh, there we go. Cool. So it was able to save the model into temp, just for fun. I think that I can actually cp temp 1. Oh, I see. It's like a whole directory full of stuff. Yeah. So so basically what we can do is do a cp-r to this whole directory. And we can put it right here. So basically we're like, copy it right here, and whoops, cp-r. There we go. Copy it right here. cp-r. There you go. Perfect. So we now have the model here, which is this one. And there we go. There's the save model. There's all this metadata, all this cool stuff inside of here. So what now, because, and I'm going to move this, I'm going to say I'm going to rename this, and I'm going to say mv main to train, because that's more descriptive of what it actually is. And now I'm going to create a new one called serve. I'm assuming they're going to show me how to serve this model out. So let's go to the next section. We don't care about that. We don't care about any of this. We just want to serve it out. And what we want to do is, I guess, do this, is we want to download the serving model. Okay, which is a little bit annoying that I have to run this step the way it's run, but I can just say touch bash or touch setup or something like this, or .sh. And what I can do is I can just take out the exclamation points, because those are just these are basically what is being run from the shell in Collab. And let's just do this. So just for speed right here, I think, I don't know. I'm going to run this first command just manually. I'm just going to run. Well, let's run this. Let's run this whole command. So let's do this. echo permission denied. Thank you. Sudo. Okay, so first I need to we'll do this sudo. Let's download this to this location. So that worked. So I'm adding that to the package repository list. And then I'm going to basically add, this can only use by root. Well, we can be root, no problem. So I'll do sudo. That looks good. And then I just do apt update. So basically, I think what this is doing is just giving us the TensorFlow serving architecture in a convoluted way because it was in Collab. And hopefully that did it. Hopefully that it says packages. Now let's go back to the example here. So it does all that. I see. Then you do sudo and you install this thing. Okay, we can do that. So I'll just say sudo that. So I could even throw that inside of here. And there we go. So we have TensorFlow ModelServer. That looks good. Hopefully we're almost done here, which is that now I need to set up this. This I think should not be horrible because I don't need that necessarily the way it is. I can just tweak this, and so I'll just call this called touch serve.sh, and let's just throw this code in there. So basically, we don't want to do no hub because I want it to run in foreground. The model director, we already know where that is. That's basically right here. And then we want to actually just run it like this. And so hopefully this just works if I say bash serve. And does it work? It didn't work. So what I'm going to do is just run this one by one. So I'll say TensorFlow model server. Does that work? Okay. So now we want to do REST API. We want to say 8501. We'll do that. And then we'll say the model name is this. We'll add that. And then we'll say the model base path would be the one, which should be like right here. So does this work? Failed to start. Load all remaining serve. Expected to have absolute path got base path 1. Oh, absolute path. Okay, well, that's fine. We can just do this. We can give you absolute path, no problem. Do this here. And we say that /1. Ooh, there we go. Look at this. We got it serving. No versions found under base path. Did you forget to name your leaf directory as a number? Okay, so maybe you don't put 1. You just do that. There we go. Got it running. So we're able to serve this. And look, if I went to open this up in browser, we should, in theory, see this thing doing some stuff. So pretty cool. Now that I got it running, though, how do we do a request against it? Now this is the request. This is the trick here. And so we want to do all this stuff to make a request. Okay, well, let's do it. First step, let's build a little bit more code. So let's make a new shell here, and we'll just say touch. First of all, source. I don't know why the virtual environment didn't work, but we'll basically say touch request .py or something like that, and then we'll go to this, and we'll say that. Okay, we'll make this. What else do we need to do? Okay, that's good. Let's go ahead and throw that in there into the request. That looks good. And then what else do we need to put in there? We need to put the requests here, so which is fine. And I think this will work. So let's go to so we'll say make request or make install. So let's install the request library. And then once this is done, in theory, what should happen is that I should be able to run this request code. That's interesting. Maybe TensorFlow just updated while I was doing this. I should be able to run this request code that will then generate my request or generate the payload, which will go against the server that's running. Because again, remember this TensorFlow is actually running right here in foreground mode. That's why I want it to be in foreground mode so I can see what's actually happening. Instead of here, there we go. We got this running. So if I type in Python request, actually test images is not defined. So let's go ahead and look at this real quick. And this is really messy code that they're giving me here, but test images. Let's go back to this. Where does test images come from? Test images. So test images IDX. I really don't know where that is coming from. So it was a pretty good start. I would say maybe that would be a good place for me to pick up next week, is to figure out what went wrong with this code and get to the payload part of it. I got the serving part correct. So I'll go ahead and stop this in foreground mode. I'll go ahead and say get status. We'll just check all this in like this, git commit, and say progress on TF serving. So great. So next up would be next week. What I'll do is I'll cover generating payloads and then making predictions on those payloads. All right. Thank you, everybody, for whoever showed up today. We'll continue next week.